this video, I'll go through an example of Gaussian elimination on a system of linear equations. So the first thing I'm going to write down is I'm going to write down the augmented matrix form of my set of linear equations. In this case, we're working with 1, 3, 1, 7. -1, -2, 3, 1, 2, 7, 7, 24. Now we need to use elementary row operations that you saw in the previous video to be able to do this successfully. The strategy we'll use is to start with the first column, look at the pivot there, and use that pivot value to eliminate everything below it in that column. So when we're doing this, row 2, our new row 2, is equal to the old row 2, take away, then we can say this is the number to be zeroed divided by the pivot. So we're going to take away the number to be zeroed divided by the pivot times row 1. Row 3 star, which is our new row 3, equals the old row 3, take away the number to be zeroed, which is 2, divided by the pivot, which is 1, times row 1. So we'll move this up a little bit so we can do it. We write down our little equivalent symbol. Our row 1 doesn't change at all. We end up with 1, 3, 1, 7. Row 2, so our new row 2 is the old row 2 plus, because we've got take away negative, row 1. So row 2 plus row 1, -1 plus 1 is 0, -2 plus 3 is 1, 3 plus 1 is 4, 1 plus 7 is 8. Now, row 3 equals row 3 take away 2 row 1. So we've got 2 take away 2 times 1, which is 0. 7 take away 2 times 3, which is 1. 7 take away 2 times 1, which is 5. And 24 take away 2 times 7, which is 10. Okay, so we've used the value in the first pivot to zero out our other pivots. Now, here we'll select our next pivot in the next column, and we're going to use that to zero out this red value here below it. So we know that row 3 star, our new row 3, equals the old row 3, take away the number to be zeroed, which was 1, divided by the pivot. So divide by our green pivot here, which is 1, times row 2. 1 divided by 1 is 1. So we're just saying that row 3 is going to be row 3, take away row 2. We'll put our equivalent symbol. First 2 rows don't change, so we'll write them in as 1, 3, 1, 7, 0, 1, 4, 8. Now, row 3, take away row 2, we've got 0 take 0, which is 0. 1 take 1 is 0. 5 take 4 is 1. 10 take 8 is 2. Okay, so we've finished going across in this direction. What we're going to do is we're going to start going back in the other direction instead. When we go back in the other direction, we're going to start with the pivot here, and we're going to zero out everything above it. Okay. So when we're trying to zero out the others, row 3 won't change, but row 2 star will now be the old row 2, take away the number to be zeroed, which is 4, divided by the pivot, times the old row 3. Row 1 star will be the old row 1, take away the number to be zeroed, which is 1, divided by the pivot, which is also 1, multiplied by row 3. So we'll write down our equivalent symbol. Okay, so third row doesn't change, so we may as well start by writing that in. We've got 0, 0, 1, 2. Okay, now row 2 is row 2 take away 4 row 3. 0 take 4 times 0 is 0. 1 take 4 times 0 is 1. 4 take away 4 times 1 is 0. 8 take away 4 times 2 is also 0. Okay, row 1 is row 1 take away row 3. 1 take 0 is 1. 3 take 0 is 3. 1 take 1 is 0. 7 take 2 is 5. We've only got one number left to zero out. As we're moving along, our pivot is now this value in green here, and we're going to zero out this 3. So row 1 star equals row 1 take away the number to be zeroed divided by the pivot times row 2. So let's do that. We've got 1 take away 0, or 1 take away 3 times 0, but still same thing. 3 take away 3 times 1 is 0. 0 take away 3 times 0, oops, sorry everyone, there we go, is 0. 5 take away 3 times 0 is 5. You might be able to tell I'm not very good with this whole touch screen thing just yet, but I'm working on it. Okay, so our row 2 and row 3 don't change at all. 0, 1, 0, 0, and 0, 0, 1, 2. And we're done. Okay, so it depends on how we originally defined our x vector, and because we haven't got a definition in terms of our x vector was x, y, and z, or x1, x2, x3, a, b, c, we'll just write x underlined as our x vector is equal to 5, 0, 2. And that's it. I hope that helps you understand Gaussian elimination a little bit better. Thanks.